Okay, there's a podcast about Pascal's triangle. So Emmett, what's this page where we're podcasting with Emmett?
Pascal, the triangle can be done multiple ways. One way in the bottom in the center right, it's showing one way, which is adding. Another way is one would so this equals 1, that equals 2, this equals 4, that equals 6. So pretty much it's to the power of 2 every time, aka multiplying it by 2.
Okay. So Emmett, let's look at this table right here.
Yeah.
Okay. What's 11 to the 0th power?
1.
And what's 11 to the first power?
11.
So that's the digits right there. And what's 11 squared?
121.
Okay, that's that row. And what's 11 cubed?
1,331. 1,406.
That's 11 to the 4th.
14,641, etc.
So those are some interesting properties of Pascal's triangle.
And another way is you could start from the bottom and subtract or possibly even divide. So yeah, you could.
Okay, so this little animation is showing how they compute each digit of Pascal's triangle, right?
Yep.
Okay, so can you imagine if you move this triangle so it was basically a right triangle? So these ones all were like sitting right on top of each other, and that you moved out from there?
That'd be kind of confusing, but I could in a way.
Okay, well, so let's look at a basic program that makes Pascal's triangle, okay?
Called Chipmunk's Basic.
Yeah, it's Chipmunk Basic, and we're going to run the program. Is that Pascal's triangle?
Yes, it is.
Okay, so see how all the ones on the left side are kind of up, right on top of each other, and the ones on the right side, kind of, it's a different looking triangle. It's kind of a right triangle instead of a equilateral
triangle,
slope.
Right?
Yeah. So it's just when you do it in basic, if you were to do this in basic, when you do your very first row, you'd have to figure out how far to push that 1. And to figure out how far to push that 1, you kind of have to know how many rows you're going to make ahead of time. If you're lazy and you said, hey, I'm just going to do the first row, and then I'm going to do the second row, and then I'm going to do the third row, and not really worry about how many rows I'm going to do, this way that I did it in basic is easier, because I don't have to know how many rows I'm going to do for it to happen. So when they compute the numbers here for each row, they basically just look from one row up to the other row, right?
Mm-hmm.
So in the basic program, here's the code for the basic program. So what I do is I use 2 arrays. And the arrays are just a set of numbers for each row. And then I say, I start with row 1, and then I basically say, hey, the very first number in Pascal's triangle is 1. And then I'm going to do this for 20 rows. And so I go for each number in each row from 1 to the row number, and then I basically say, hey, the new number is exactly what this formula is. I just look if array B is the new row that I'm computing and row A is the old row that I already have computed, then I can calculate it. And then I go and I just transfer all the old row to the new row. And then I basically keep doing that 20 times. That's how I do it. So that's a basic program on how to do Pascal's triangle. Pretty cool, huh, Emmett?
Yes, it is.
Cool.